And in today's episode, among other things, you'll see a humanoid robot with an extremely realistic face that can look at you, listen to you, and talk to you in real time. Meanwhile, scientists are also trying to teach robots to do something that until recently seemed impossible. Remember what they were doing just minutes ago. Learn from their own mistakes and continue complex tasks. At the same time, a European startup is trying to completely reinvent the way robot bodies are being manufactured. They are using something that looks much more like a high-tech loom than a regular assembly line. But the innovations don't stop there. All right, in China, a gigantic urban transportation system is transforming an entire mountain into a kind of colossal escalator. And at the other end of the scale, scientists have just created a QR code so microscopic that it's smaller than many bacteria, and it is capable of paving the way for new forms of data storage. Let's understand all of this. Hello, impressed viewers. I'm Carlos Alves, and you're watching Amazing Reality. And there's a technology that's already working in more than 180 countries and that many Brazilians are already using. It's Nomad. And I'll be direct, okay? It helps you stop losing money. Nomad converts your money to the currency of the country you're in, whether it's Brazil or abroad. You open your account in just 5 minutes. Get the virtual card and then the physical one. You travel, shop online, or subscribe to digital services, all with no hidden fees or surprises. And pay attention to this, okay? Nomad has launched its own SIM card, and since it's international and you only activate it when you arrive at your destination, it works on Android and iOS and gives you internet in over 30 countries. And if you're a Nomad PES level 1 to 4, you get 1 gigabyte for free. At level 5, the internet is unlimited for 15 days. And Nomad is giving $20 in cashback to new customers. But it's only for those who open an account right now, using the code RI20 on your first currency exchange transaction. So don't waste any time, my friend. Open your account using the link in the description or in the pinned comment. There's even a QR code on your screen. Get your cash back now and stop spending way more than you need to. And of course, you also help Realidade Impressionante keep bringing you the cutting-edge technologies you always love to see. You help me, I help you. Deal? Since it was created, artificial intelligence has been trapped inside screens. That's how we've been using it, right? But now it's starting to get a face, something that doesn't really identify it as a being. A robotic startup based in Shanghai called Aheadform has just shown the world a new humanoid robot that's drawing attention for its appearance, which is almost unsettlingly realistic. The model is called Orange F1, and the company's proposal is to take artificial intelligence out of the screens and put it face-to-face with us human beings. The Orange F1 has an extremely detailed robotic face, which was developed to allow, let's say, natural social interactions with artificial intelligence systems. To achieve this level of realism, the engineers created a structure with synthetic bionic skin and more than 25 to 30 facial micromotors that are capable of reproducing the extremely subtle movements our faces make. This includes blinking, micro-expressions, smiles, and synchronized eye movements, thus creating something much closer to real human communication. But appearance is only half of the story. These robots have been designed to integrate directly, including language models and vision language systems, allowing the robot to perceive its surroundings, recognize human emotions, and respond with somewhat natural speech. And in a recent demonstration published by the company itself, the researchers showed exactly how this interaction works in practice. In the experiment, F1 was connected to an AI model called Omni, a system capable of processing vision, audio, and language, all simultaneously in real time. Unlike traditional systems called VRM, which combine only vision and text, the Omni model allows for a complete multimodal interaction. This means that the robot can see the environment, hear people, interpret the context of the conversation, and respond with synchronized speech, all happening live during the human interaction. In practice, it's not just a chatbot with a face. Okay, it's a completely new form of interface. Finally, artificial intelligence no longer exists only inside screens. And now it starts to manifest itself through a physical robotic body. According to Aheadform, the F1 was specifically designed as a research platform for the future of embodied artificial intelligence, paving the way for a new generation of interaction between humans and machines. The ultimate goal is to create robots capable of forming emotional bonds with people, but making robots that can converse and express emotions is only part of the challenge. Because in the physical world, here in our world, talking is not enough. Right, isn't it? Robots also need to act, and that's exactly where a new technology comes in that's promising to redesign robots and give them what they've always lacked. If you watch the human hand for a few seconds, my own hand, I'm not a robot. Even if it sometimes seems that way, you'll notice something impressive. It can manipulate almost any object, including my robot, which I need to show you. If I don't, I can't include it in the description. As a product for sale, it's available on Mercado Libre, on Shopee. You can check it out there. This one is the Bad Robot. Well, despite all the advances in artificial intelligence, many robots are still incredibly clumsy when they need to manipulate objects in the real world. Opening a box, holding a tool, or simply picking up something delicate without breaking it, yes, that's a big challenge for machines. Now, a North American startup called Robotics believes it has found a way to solve this whole problem. So, the company developed a system that combines a highly articulated robotic hand with a smart glove worn by humans. This glove very accurately captures all the movements of a human operator's fingers, and these movements are transferred directly to the robotic hand, thus creating what the engineers called a digital twin of the human hand. In practice, this allows robots to learn tasks by observing and exactly replicating the movements of real humans. According to the researchers, this kind of approach solves one of the biggest obstacles in robotics: training data. Why does training robots using videos of humans usually result in inaccurate information? Virtual simulations? Well, those also tend to fail when faced with the real world. But when the human hand and the robotic hand have practically the same mechanical structure, the captured data becomes much more accurate. The ultimate goal of Origami Robotics is to create a model capable of performing universal object manipulation. In other words, robots that can interact with practically any object that a human being can manipulate. The company's first devices are already being shipped to major artificial intelligence research laboratories. Among them are Amazon's laboratories, which are interested in using this technology to make robots much more skilled. But there is still another problem, which is even deeper in modern robotics. Even when robots can manipulate objects with great precision, they still have trouble remembering what they are doing. For the most part, today's robots operate with a memory that's almost like that of a goldfish. They can process images and information, and all of this happens for just a few seconds. But quickly, they lose the context of what they were doing. This greatly limits the type of tasks and what machines are actually able to perform. Most robots can complete quick actions, but longer tasks like organizing a kitchen, preparing food, or carrying out a sequence of complex steps have always been a challenge. Now, a company called Physical Intelligence has announced a new artificial intelligence architecture that could completely change this scenario. The technology was named Multi-Scale Embodied Memory, or simply Multi-Scale Embodied Memory. The idea is to allow robots to stay focused on a task for up to 15 minutes. This way, they can remember what they've already done and what they still need to do. To achieve this, the system uses two different types of memory. First, short-term visual memory, which is based on video. This system allows the robot to remember recent details of the environment. For example, it can remember where an object is, even if its own arm blocks the view of the object. But to avoid processing overload, the system also uses a second type of memory, which is textual and long-term. Instead of storing all the video frames, the robot creates small summaries in natural language of what is happening, something like an internal note. For example, I opened the refrigerator door, I picked up the plate, I cleaned the counter. These small narratives help the robot maintain the context of the task it is performing. And this brings a very important advantage: the ability to learn from its own mistakes. That's something that some humans still can't do, right? Well, in a test demonstrated by the researchers, a robot tried to pick up an object and failed on the first attempt. But since it remembered the recent mistake, it automatically adjusted its strategy on the second attempt, and it managed to complete the action smoothly. This kind of adaptation is essential for real-world tasks. For the researchers, this type of memory could be a very important step to bring robots closer to real environments, to our work. Well, if robots are getting smarter and smarter, then another question inevitably comes up. How can we build complex robotic bodies that are capable of keeping up with all this new artificial intelligence that's coming? Let's try to understand this now. Let's go. There's a problem that has been holding back the evolution of robots for a few decades. Building the bodies of these machines, creating robotic hands with dexterity similar to humans, for example, can require hundreds of tiny mechanical parts Tiny screws, cables, bearings, delicate joints, all assembled by hand in a slow, expensive, and extremely complex process. Now, a startup from Hungary believes it has found a pretty radical solution to this kind of problem. The company Alonics, based in Budapest, has just raised $7.2 million in investments to develop a new way of manufacturing robotic bodies. And their idea is that instead of assembling robots piece by piece, the company's technology literally weaves the robotic limbs as if they were fabric. The system, called 3D fabric braiding, works in a way similar to a high-tech industrial loom. First, a basic skeletal structure is placed in the machine. Then, high-strength fibers, elastics, artificial tendons, and even sensor cables are automatically braided around this structure. The result is an almost complete robotic component, a single piece that is flexible and structurally strong. According to the company, this method eliminates the need for hundreds of individual parts. This allows a digital file to go from a computer-aided design to a functional prototype in just a few hours. And that's something that would normally take several weeks. Using traditional methods, the company's new machines are already 5 times faster than the first prototypes developed by the team. And Alonics' goal isn't necessarily to create its own robots. The company wants to become a kind of manufacturing infrastructure for the entire robotics industry. Companies could design their robots on Alonics' platform, while the startup would be responsible for manufacturing those robotic bodies. And while some companies are reinventing how robots are built, others are expanding where these machines can work. The ocean floor remains one of the most hostile environments on our planet. Crushing pressure, total darkness, and complex environments mean that much of underwater operations rely on highly specialized equipment. Americana decided to take this technology to a new level. The Houston-based company unveiled a new underwater robot that can operate continuously on the ocean floor for up to 30 days. The equipment was named Momentum Electric Hove, which is the acronym for Remotely Operated Vehicle. These machines are widely used in activities such as underwater infrastructure inspection, platform maintenance, deep water construction, and drilling support. But this new robot model was designed with a slightly different approach. Instead of using traditional hydraulic systems, the Momentum uses fully electric propulsion, which improves energy efficiency and reduces the need for maintenance. According to the company, this allows the robot to remain in operation for much longer periods. The other highlight is its adaptability. The vehicle has a modular system with plug-and-play sensors, which allows technicians to quickly install new tools. In addition to manipulators or sensors, depending on the mission, it also features an advanced 360-degree vision system, providing human operators with a complete perception of the underwater environment. But not all major technological innovations are happening only in laboratories or at the bottom of the sea. In some parts of the world, engineering is completely transforming the way we humans and the cities we live in can function in a way that's a bit more pleasant for us. And an impressive example of this has just appeared there, in China. There or over there, I guess it's over there, depending on where you're watching the video from, right? Isn't it? Known as the Mountain City, this gigantic metropolis in China was built on cliffs, valleys, and steep slopes. There, getting from one neighborhood to another often means going up or down hundreds of meters in elevation. For many residents of Yushan County, for example, simple daily tasks have always required long walks along narrow roads and very steep slopes. In some cases, a climb can take more than an hour. Now, that has completely changed. There, the city has just inaugurated a very impressive system, which is known as the Yushan Goddess Escalator. With a length of 905 meters, it has become the longest outdoor escalator in the world. But the project goes far beyond a single escalator. In fact, it is a complex network of vertical transportation that follows the natural contour of the mountain. The system includes 21 escalators, 8 elevators, 4 moving walkways, and several pedestrian bridges. Together, these structures connect different levels of the city along a route that reaches 242 meters in height. That's approximately equivalent to an 80-story building. The most interesting thing is that the entire project was designed to follow the shape of the mountain, instead of going around the slope in an artificial way. This allows the natural landscape of the region to be preserved, including the famous visits to the U Gorge and the Three Gorges. But while some technologies are getting bigger and more important, others are going exactly the opposite way. Take a look at this. Nowadays, QR codes are everywhere. In fact, there's one right here on the screen. It goes straight to my book, so check it out if you want. Packaging, restaurants, digital tickets, payments, all of these use QR codes nowadays. But now imagine a QR code so small that you simply couldn't see it with the naked eye. Not even with a regular microscope, okay? That's exactly what scientists at the Vienna University of Technology in Australia managed to create. A microscopic QR code with just 1.98 square micrometers of area. To give you an idea of this scale, that's smaller than many bacteria, and it's so tiny that it can only be observed using an electron microscope. With this achievement, the team officially secured a new record in the Guinness Book. But the goal of the research goes far beyond breaking interesting records. It is directly linked to one of the biggest technological challenges of the modern world: data storage. The amount of information humanity produces is growing at a very fast pace. Data centers, scientific archives, historical data, cultural records, all of this needs to be stored for several decades or even centuries. That's why the researchers worked in partnership with the German company Terabyte. They specialize in long-term storage technologies. The microscopic QR code was engraved on a thin ceramic film using highly precise ion beams. Each pixel of the code is only 49 nanometers in size. Just so you have an idea, this means that the elements of the code are about 10 times smaller than the wavelength of visible light. According to the researchers, this technology could pave the way for new forms of data storage that are extremely durable and reliable, according to them. If you like this episode, please like and check your subscription. Thanks for staying with me. Remember, if you want to buy any item that's here on the table, feel free. Just click on the description and you'll find it there. My book is also in the description. The link to create your account on Nomad is in the description. And the link to subscribe to Aria, our artificial intelligence, is in the description. All the information you need about this episode is also in the description. Thank you once again for following me. All right. Thanks. Bye. See you later. Just click on one of the two suggestions and I'll see you in the next one.